This short video will discuss the problem formulation for example 2, which is provided on the lesson 12 handout. This is an example of an aggregate planning problem where a firm is simultaneously planning a production and labor schedule to meet specified demand at the lowest cost. The problem formulation will consist of a problem statement, the decision variables, the objective function, and the constraints. In this type of problem, I'm not going to be so concerned with defining variable names for the decision variables and writing mathematical statements for the objective function and constraints. I simply want to put together the problem formulation to understand the problem in words before trying to go to Excel to build the model. This will make building the model much easier. So in this case, it mentions the SureStep company, which has established demand for the following 4 months for its shoes. Information on the number of shoes on hand and the workers on hand is provided. We also have cost information about the cost of hiring and firing the employees and the cost of employing people. And there's a holding cost and raw materials cost provided. The problem statement will simply be that SureStep needs to establish a production and labor schedule to meet specified demand at the lowest possible cost. If we wanted to, we could add a sentence that took into consideration some of the other the other constraints in the problem, but this should be sufficient for now. The decision variables are 4 sets: the number of units to produce each month, the number of employees to hire each month, the number of employees fired each month, and the number of overtime hours used each month. An important thing about this problem is that this particular firm has the option, if they need to increase production, of hiring new employees or possibly using overtime hours for its current employees. And the model is able to balance the costs of these things. The company wants to minimize total costs, which includes several costs. They include regular and overtime labor costs, materials costs, inventory holding costs, hiring costs, and firing costs. So we want to minimize the sum of all these costs for the entire period. There are several constraints in this problem. The first constraint is that production has to be less than or equal to the production capacity. This brings up the question of how much production capacity the firm has. And what it says here is it takes 4 hours of labor and $15 of raw materials to produce a pair of shoes. So it's important to realize that the production capacity is equal to the total hours available divided by 4. Total hours available will include both regular hours available for each employee and any overtime that they're assigned. The next constraint is that the units available to meet demand has to be greater than or equal to demand, because the problem states that we want to meet demand on time. The units available to meet demand could be made up both of beginning inventory or of the current period's production, because it says that production in a given month can be used to meet this month's demand. The last constraint is that the overtime hours assigned has to be less than or equal to the maximum overtime hours. There is a maximum on overtime hours because at most we can assign a certain number of overtime hours to each employee, and that's 20 per employee. The set of constraints in this problem is unique to this problem, and there's certainly many other constraints that could be included in these types of problems. Examples might be constraints on the amount of ending inventory we can hold because of a warehouse constraint. We might, in some problems, not be able to use all of the current month's production to meet demand. We could have limitations on the number of employees that we can hire in a month because of training capacity constraints. So there are many things that might have to change in these problems. The important thing to remember is each of these problems is unique. And in practice, you would simply have to go through probably several iterations and discuss the problem and the solution with a number of people before all of the constraints were really established. This will conclude this part of the video, which discusses the problem formulation. So in the next brief video, we'll actually set up and solve the problem.